Hello, welcome back to STEM Online Academy. My name is Jason. I am the founder and head of STEM Online Academy, for those of you who don't know. And we specialize in helping undergraduate students who are taking calculus and physics courses, uh, you know, strengthen their problem solving skills uh, immensely for midterms, hard midterms, and hard exams. So let's get right to the bulk of today's video. Right? We're going to look at why a lot of you guys actually think the IVT does more than it actually does. Okay. When I mean IVT, this guy right here that I've highlighted in blue, IVT, right? Intermediate Value Theorem. Okay. For those of you who have heard it, the Intermediate Value Theorem is a very interesting theorem. Okay. Now, as I said, a lot of you are misunderstand IVT. Okay, IVT. A lot of you think somehow the IVT is just somehow what's the word proves that a root exists, uh, and so the if it proves that it exists, there has to be some form of uniqueness. No, this can't be further from the truth. Actually, that's not the case. Right? That's not what IVT tells us. Quite often, when it comes to definitions and theorems, the reason why a lot of students don't understand them is because they don't understand, first and foremost, what they are reading for A or B reason. Okay? And pretty much that's the trap, right? For you think that the root exists, but the root must be unique. You imply that if the root exists, it must be unique. No, that's not true. That's a major trap in your thinking. Okay? IVT proves not uniqueness. What does it prove? Let's look at the theorem here, right? So the theorem for IVT states fx must be a continuous function on the closed interval a comma b. That's number one, the first condition. Second condition of the theorem states that let capital N be any number between f of a and f of b, such that n is sandwiched between f of a and f of b. And if that is the case, if you look over here, there exists a number c belonging to a comma b, which is open, such that f of c equals capital N. That's the theorem from the IVT theorem, intermediate value theorem. Okay. From that theorem, that tells you it doesn't prove uniqueness. It proves existence, right? Because of this guy down here. Look at this quantifier, right? Right. The quantifier tells you what it's proving. Okay. So it proves existence. It does not prove uniqueness. It does not give us, you know, some type of. It doesn't give us an exact form of a location, if you can say furthermost. Okay. Um, so today we're going to be fixing that very mistake. That's what I'm thinking. Okay, let's fix that mistake. It's a concept that a lot of you have trouble with. Don't get me wrong. When I was in university, the first time I took an analysis course, I had trouble with it too. It's not that easy. I have to be honest. Okay, actually, it isn't easy at all at first. But I'm going to help fix that mistake using what a lot of you know or don't know. It depends if you're new to the channel. We're going to be using my famous technique. Okay. My systems technique. Okay. So the systems technique for solving advanced mathematical problems. Okay. And the systems technique goes like this, right? Starts off with one. You want to be able to visualize the problem that you're dealing with. Okay. Then we are going to go to the next step, which is model. Then we'll go to the next step, which is execute. And then finally, the last step, we want to verify. Verify better be in there, because what type of math are we doing if we're not verifying our proofs, our solutions, and all of that? Okay. By the way, I want to say a thank you to a viewer A viewer who watches my videos came to me, and he wrote in the comments he was requesting I do some videos on IVT, Rolle's theorem, Taylor's theorem, and so forth. We'll get to those much later, but today we're going to do IVT. I have to say thank you to him because I like IVT myself. Okay, so yeah, I like analysis. It's the fun part of calculus, right? So yeah, let's get right to some of this. Okay. Well, before we get to that, I want to mention something personal about myself. Okay, for those of you who don't know, right? There was a time where I struggled with math. I would get, especially problems like these. There was a time where I struggled immensely. Right? Well, I didn't struggle with advanced math. Actually, I excelled a lot in advanced math. But in my junior high years, like grade 8, grade 7, 8, I was struggling with math immensely. Okay. So I would get stuck on problem solving questions like these. All right. And it wasn't because the algebra or the computation was hard, right? That's not it, right? Quite often it isn't, right? People think math is, oh, I'm computing something. Oh, I'm doing just the mechanics, the algebra. No, 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 not even close. The computation definitely not, but even the mechanics in algebra, which is important. You need to know the mechanics in algebra before you do any advanced math. Otherwise, you're not doing math. But yeah, the algebra is not the mechanics of the algebra is not as important. What matters is if you're able to reason. Okay, when you're doing problem solving questions. All right. And as I said, it wasn't because the algebra was hard. The hard part was not knowing what to use when I did problems, whether they were word problems or they were basic algebra problems. I was getting confused what to use, especially word problems. Okay. Then what happened was that two teachers truly, truly changed my life. Right. They changed that for me. They taught me to stop memorizing certain equations or little words or whatever to use, right? And they taught me, um, yeah, they taught me to stop memorizing blindly and actually take a deep breath. That's one of the most important things is taking a deep breath, right? So that's why you don't get anxious because if you're anxious, you can't think clearly, right? Take a deep breath and break the problem into a system that you know will work. Now, how do you know? How would I know? How do you know what system that works for you? Well, that's a very good question. But I know what system worked for me, and my life's goal is to help students use the system and hopefully change their lives for the better, right? Because education is a must, right? So I broke it into a system, and that system helped me master mathematics and physics uh, in university. And now I just teach it to students, as I mentioned, right? For hard exams, hard midterms, but also for people who have not just undergraduate students who wanted to know how to tackle hard uh, exam questions, midterm questions, but also for independent learners too. Maybe you have a passion for math later on and you want to start from the very beginning. Well, doing starting from the beginning is a very good place to be in. You're in the right channel. Okay, so at least for advanced mathematics, right? And this, let me get back to me again. And that system that helped me was the visualize, model, and execute verify method system. Okay. So let's start off with the visualization. Let's get to the problem. Okay. Start off with the problem. So we want to be able to visualize this. Okay, so let's first visualize the graph. Now, I should mention actually, let's get to the desktop. Okay. I actually have a good simulation that I made here. This will be really fun. I think you will enjoy this. Okay. Now, what this simulation is saying, right, is that at x equals 0, right, the function is going to be below the x-axis, right? So pay attention. below the x-axis. Now at x equals 1, the function is going to be above the x-axis. So look at those two curves there, right? One is going to be below, one's going to be above. So if the graph is continuous, right? If you look at the graph being continuous, okay, and it is continuous. What I mean by that is that there's no discontinuity of any sort. There's no jumps, no anything bizarre. Otherwise, we would not be able to use IVT, right? We can't use IVT if the function is not continuous. Sorry, I need to get some water there. Let me play it again. All right. So, as I said, at x equals 0, the function is below the x-axis. At x equals 1, the function is above the x-axis. Now, if the graph, right? Not if, the graph is continuous, sorry. The graph is continuous. It has to cross the x-axis, all right? And you can see it does. And that's where that root exists between 0 and 1. That is exactly where and why IVT applies. By the way, this is a good graph to show you this, because I've never came across this. But what if you have a devilish professor who gives you a question to prove or solve, and he doesn't say use IVT to solve it? That would be devilish. That can be tricky, because most of the times they tell you that you have to use IVT to prove it, right? But what if you have a professor who doesn't tell you that? Then that could give you some type of um, that can be hard. That can be very hard to be able to distinguish when to use it. But as I said, certain things will automatically be able to give you notions of when to use it, right? The function has to be continuous, so no jumps or discontinuities, okay? And it needs to cross the x-axis, okay? All right? These could cross the x-axis, right? And that's how you're going to know when if IVT is going to apply, okay? Now the graph is going to go from negative height to positive, right? Positive height, as you can see here. I'm replaying the mathematical model so you can see it. So it has to hit 0 at least once, okay? And at least once, not exactly once. Let me clarify the semantics, because quite often people are getting confused, and that's what people don't understand when it comes to analysis, the part of calculus, which is tricky, is that it's not about formulas or equations. It's the semantics of calculus that is screwing people up, right? Remember, it has to hit 0 at least once, not exactly once, at least once. Okay, that's how IVT operates. All right, so I hope that makes sense. Now we want to go to the next step, right, of my system, my systems technique, and that's modeling it. You can say this is still a part of the model. This is mainly the visualization part of it. But for the model, there are 3 claims that we want to make. 3 different claims. There's existence, there's uniqueness, and there's location. Now, with existence, is there a root? That's what we have to ask ourselves. Is there a root? Uniqueness, is there a root? Location. Well, if you look at this graph, right? Can you answer any of those 3 questions in your head? By the way, for location, I mean what smaller interval contains that root? Okay. If we go back, just to remind yourselves what I'm talking about for the specific question, right? Remember, the question says we want to prove that f(x) equals 0 has a solution, 0, 1, prove uniqueness. And explain why IVT alone doesn't prove uniqueness, and determine whether the root lies between 0, 1 half and 1 half, 1. Okay? That's what I meant by location. Which smaller interval contains the root? And IVT is only going to help us with the first part of this claim, right? It tells us where it exists. It tells us the root exists, sorry. Yeah, let me think. Yeah, it tells us the root exists because the function changes sign on the interval, right? Function is going to change sign. Right? If you go back to our diagram, right, the function is going to continuously change sign on the interval. Now, to prove the uniqueness, we need a separate idea. Okay, I'm getting ahead of myself. Sorry. So yeah, you see how the function curves up and one that curves the other way. Sorry, there's only one function. Yeah, the yellow curve that curves up. Okay, that curve there, right, is a very interesting curve. Okay, and you can see that the root exists because the function is changing, right? Function changes on that continuous interval that I talked about. Okay, I hope that makes sense. By the way, if you're not following, ask me questions in the chat. I know I'm not live. Live shows will come back eventually. Just been very busy lately, that's why. But ask me questions in the chat and I will answer your questions. Okay, once I upload the video. So on the continuous interval. Now we want to prove the uniqueness, but we need a separate idea for this. For uniqueness, we need something that is called monotonicity. Or something can be monotonic, right? I'm not going to go through that with you. I'm going to jump a little bit because I feel like I'm taking up some time with definitions and theorems. I put up the theorem here just to make sure that you can remember what I'm talking about when it comes to IVT, right? The theorem here. Okay. So let's move to step 3, right? Execute. Okay. So we know the function is continuous. Okay. So we know that IVT is going to be used. Okay. So we made our life easier with that. Now, the function, right? The function f of x equals x cubed plus x minus 1, this guy right here, right? Function, this guy. Okay, this guy right here. We can look at it. Okay. The function is negative at 0, right? And positive at 1. Okay. And I can prove that right now because look, f of x, just 1 second. Sorry about that. We know that f of x equals x cubed plus x minus 1. Okay, if you plug in, you want to plug in those points. Okay, we want to plug in, those coordinates 0, comma 1 here, correct? So let's evaluate and see where f of x is going to be positive and negative. Okay, so f of 0 is going to give us 0 cubed. Sorry about that. 0 cubed plus 0 minus 1. Okay, and that gives us 0 plus 0 minus 1, which gives us 0 minus 1 is negative 1. Right, so equals negative 1 is f of 0. Well, that means this implies automatically that f of 0 is strictly smaller than 0. Okay, so we're looking at some sort of monotonic behavior here. Okay, so that's the first case. Okay, that's case 1. I'm going to say case 1. 1 at x equals 0. Then we're going to have case 2 at x equals 1. Substitute x equals 1 into the function and see what happens. So again, we have f of x equals x cubed plus x minus 1. Therefore, we get f of 1 is equal to 1 cubed plus 1 minus 1. The algebra is very easy, right? So this becomes 1 plus 1 minus 1. That gives us 1 for f of 1. We know that f of 1 is strictly greater than 0. Okay? So that proves the point, right? That proves the point f of 0 is negative and f of 1 is positive. Okay, I hope you're following along. Okay? As I said, the function is negative at 0 and positive at 1. And that graph and our model proved that, right? That I did in the visualization step. Okay? Now for uniqueness, right? When it comes to uniqueness, what I mean by that? Well, what do I mean by uniqueness? What do I mean by uniqueness? What do I mean by uniqueness? well, first off, I'm talking about in terms of the derivative. Think of, what's the word? Relating it to the first derivative test. Okay. If you were to look at this using the first derivative test, I won't go through the first derivative test, but that's the way to know if the derivative is going to be positive, right? The derivative is positive, right? And that means that the function is always increasing, right? And we have proof of that, right? We have proof of that in our model, okay? Right, so it's always increasing, okay? So you can see that our function is always increasing, right? That yellow curve, the fact that it's curving up, it's increasing. Now, an always increasing function can cross the x-axis, but it has to do it at most once. Okay, at most once, an increasing function has to go through the x-axis. So now we have some very interesting pieces. We have two interesting pieces, right? IVT gives us at least one root. I think you can agree. Increasing behavior. What I mean IVT, it gives us at most one root. Okay, at most one root. Sorry, I shouldn't say at most. IVT gives us at least one root, not at most, at least one root. Okay, we need to be careful with what we're saying here. Okay, in mathematics, we can't say nonsense. We have to be very precise. Okay, and that's why, and my my coaching services are the same. Um, like very rigorous. It's not for everybody. Okay, I teach the calculus at a high level. It's the same calculus that everyone learns, but the questions that I come up that students come across when they're with me are a bit daunting. But math is supposed to be that way. It's never easy. If you've had teachers, too many teachers give you easy math problems, they ain't teaching you no math, my friends. Sorry about that. That's not math. That's baloney. Okay. But that's the uniqueness of my coaching services, just to let you know. Okay. But as you can see here, right? As I said, at least, okay? There's at least a IVT helps us at least one root, okay? So IVT gives us at least one root, as you can see there in the graph. All right, so increasing behavior, but there's increasing behavior at most one root. So make sure you're understanding the difference in the terms. Again, if you don't understand anything, contact me in the chat below. So we want to prove, well, together they actually prove something. They prove that there's exactly one root. Okay. Now, we may need to locate this root. Okay, so we need to locate, I want to locate the root. Let's locate, let's make some room here. Locate the root. Locate the root. We want to figure out what half includes the root. Now we have a midpoint 1/2. I hope you guys agree, right? That we want to determine whether the root lies at 0, 1/2 and the coordinate 1/2, 1. That 1/2 is the midpoint, right? The midpoint of these coordinates. I think you can agree with that. Okay, so let's locate the root at x equals 1/2. Okay, so let's look at another case. This is case 3. I mean, you don't have to say case 3, but I'm just splitting it up. Okay, so case 3, when we have x equals 1/2. Okay, so evaluating at f of x equals x cubed plus x minus 1. Okay, so at x equals 1/2, we'll notice that we get f of 1/2 is equal to 1/2 all cubed plus 1/2 minus 1. Okay, so now we're getting this. And that means that, let's go to the next page, that f of 1/2 all cubed is 1/8. Okay, see the other part here, plus 1/2 minus 1. That gives me f of 1/2 is equal to -1/2, right? -1/2 plus 1/8. Get a common denominator. F of 1/2 is equal to, let's see, -3. Yeah, -3. -3/8. So it would be f of 1/2. Okay, so at x equals 1/2, the function is going to be negative, right? So this will imply that f of 1/2 is strictly less than 0. By the way, I use the term monotonic quite a bit here. We're not looking at monotonic sequences if anyone's getting confused. No, I'm just using it as a terminology to be very precise. The fact that I'm looking at where the function is positive and negative, because if it's positive or negative, it's strictly less than or strictly greater than. That's like a monotonic behavior. Okay, so at x equals 1/2. All right, so negative. Now at x equals 1, the function is going to be positive. I've already did that. I already proved that. I have to do it again. F of 1 is positive. Okay, so f of 1 is positive. So the sign change actually happens between 1 and actually happens between 1/2 and 1. Look carefully. The sign change is going to happen between 1/2, the -3/8, right? When f of 1/2 was -3/8, and 1, because 1 was increasing when f of 1 was greater than 0, and f of 1/2 was -3/8, right? So that's where we're having that sign change. Okay. Therefore, the unique root, right? So therefore, I'm going to say, therefore, the unique root lies the unique root lies in 1/2 comma 1. That's where we have to look at it. Okay. And then finally, we have our verify that we need to look at. Okay. The last, let's say technically last. It is last. Yes. Yes. Verify is the last part of my systems technique. Now we want to verify this answer. Okay, we want to verify the answer. We proved existence using IVT. I think you can agree with that. We know that we proved uniqueness of the fact that the function was increasing. Okay, uniqueness and existence. So the final conclusion for this logic is the fact that there is exactly one solution. Okay, right? The fact that there's exactly one solution. Right. So this actually implies. Okay, this implies that there exists, right? This actually implies there exists exactly one solution. One solution. One solution. One solution in 0, 1 and 1/2, 1, 1/2, 1. Okay. And that's what's the fundamental thing of importance. So IVT alone does not prove uniqueness. Okay, it proves existence, but uniqueness is used to show if the function is increasing or whatever. Okay, it only proves the thing about IVT only proves the main point is that a root exists. That's what you need to get through your heads, that a root exists. Okay. So if the problem felt confusing, I hope it didn't. It doesn't mean that you're bad at calculus, right? Trust me, it doesn't. It just means that you just may need to review things or whatever, right? It just means, maybe you have to review things, but it may mean the theorem's logic is actually hidden, was hidden. Sorry, I have to correct myself. So hard calculus exams are going to often test you, uh, test whether you know what a theorem does, like really know what the theorem does. You may assume that you know what the theorem does, but you don't actually know it until you've done a hard exam. So remember, IVT, right? IVT gives uniqueness. Monotonicity just proves the uniqueness. So IVT proves existence. Sorry. Ah, something's wrong with my mouth today. Everything's slipping out of my mouth. IVT proves existence. Okay. All right. IVT proves existence. Monotonicity proves the uniqueness. The monotonicity meaning where f of x was greater than 0, f of x is less than 0, if it's increasing or decreasing. We need to know that behavior, so that's why we were able to determine uniqueness from monotonicity. But the IVT proves existence. So IVT proves existence. IVT proves existence. Okay, I want you to jot this down in your notes. IVT proves existence. Monotonicity gives uniqueness, and a sign check will give you a location of the coordinates where you need to find. Right, so that's pretty much the entire problem. All right. Okay, so that is it. If you understand calculus in class but freeze on proof style exam questions, I do have a solution for you. I do have a solution. And what you can do is you can download my free guide on my systems technique. Okay, it's a free guide. There'll be a link below to look at my systems technique. Okay, and it's going to tell you how to deal with hard calculus based problems. Okay, so go down there. It's free, right? You can get it in the free guide there. All right, it's called 7 Hard Calculus Exam Tip. Now, if you, for A or B reason, uh, let's say you understand the techniques from that, right? From my seven hard calculus exams, 7 hard calculus exam traps. Sorry, they're traps that you should look out for. Um, if that's not enough, I do have there's my new book I've been talking about. If you've been paying attention, they would. But I have a new book, and that book is called Axioms. It's a prerequisite on the language of mathematics, um, and language and the reasoning used to understand um, things like analysis slash calculus, right? Right, because quite often what we're going to be doing in this channel is we're going to be looking at not just the calculus but the analysis behind it. And for that, you need to understand proofs. So if a problem like today was confusing you, is because I was referring to definitions slash theorem. Okay. So that some of you who are watching probably only took calculus at a basic level and you've never seen like what the hell is a definition, what is a theorem, what is a direct proof. If you don't know what a definition is, first off, in any of your math classes, yeah, you're in trouble. You probably want to check out my book, right? That's why I made it. That's why I wrote it, because I wanted to make sure that I can help you guys like understand how math works, the problem solving behind it. Okay, and yeah, it's going to be really, really, really handy. Okay, it's a very well made book. It's available as an ebook. Maybe paperback will come down the road, but I suggest you get that book if you're not understanding uh, proofs, because I'm going to be doing proofs. Well, I have been doing proofs even from before, off and on, but there's going to be some other proofs coming up, so it's going to help you understand things. So look into that. You may want to check it out. Okay. And I'm going to be talking about it tomorrow, right? I'm going to be talking about that's what tomorrow's episode is going to be, and I'm going to show. I'm going to be a more. It's going to be more personal. I come up once a week where I show my face, and I'll be talking uh, for 20 minutes about whatever topic that's obviously related to the channel. Um, But yeah, I'm going to come up tomorrow. It's going to be an interesting one. We're going to investigate the book and some common misconceptions that people have with mathematics, proof-based mathematics. It's going to be very interesting. Okay, so that's going to be tomorrow. And finally, so stay tuned. Okay, and finally, if you're having trouble in general with mathematics, I'm available for coaching. My coaching services are available. Right, I'm an expert university coach. Okay, and that is it. Like and subscribe to the channel if you're new. Please like and subscribe. And for viewers, if you viewed for past viewers who already viewed my things but haven't actually subscribed yet, please subscribe if you're watching right now. Right, so subscribe. It really helps the channel. A lot of more interesting things to come, guys. Don't worry. And yes, have a great day. Bye bye.